Okay, section 6.4. This is all about solving equations containing rational expressions, or as you'll probably hear me call them, just solving rational equations. So the way that we're going to do this is essentially the second method of the last video in the simplifying complex fractions, the LCD method. And so there's only one objective, and that's to solve rational equations. And we're going to use that LCD method. So we just have a bunch of examples to work through, and then there's some practice problems at the end. The way that we want to look at this is we want to look at the LCD of our fractions every single time, in this case 2, 5, and 10. And this is going to be equal to 10. They all have 10, or they all can multiply up to 10. So then what we do is we multiply everything, and notice I'm including the equal sign because this is getting distributed to both sides of the equation, and we cancel and reduce. So when we multiply 10 divided by 5, we end up with 2 times 4x. And then we multiply 10 divided by 2, we end up with 5 times 3. And this equals 3x. And now the fractions are gone. We can simplify and solve. 8x plus 15 equals 3x. We'll subtract 3x from both sides and at the same time subtract 15. And we have 5x equals negative 15. Divide by 5. And we have x equals negative 3. And then this should get checked. Check has a C in it. So I'm going to check it over here where I have space. Separate that off from the regular work. And we're checking it in the original, so this is 4 times negative 3 divided by 5 plus 3 over 2 should equal 3 times negative 3 divided by 10. This is negative 12 over 5 plus 3 over 2 should equal negative 9 over 10. I need to multiply this by 2 and by 2, this one by 5 and by 5 to be able to add these fractions. So this is going to be negative 24 plus 15 over 10, and that should equal negative 9 out of 10, or in other words, negative 24 plus 15 should equal negative 9, and it does, so we know our solution is correct. So that's a basic example. All our denominators were numbers. So the next couple are going to start adding in more complicated denominators. So in this one, our LCD, it's the LCD of 3x and 3x. And so that's going to be 3x is the thing that encompasses all of them. Once again, we multiply by 3x and distribute to all three or all pieces of the equation. 3x divided by 3 is going to get us 3 times 3. Minus 3x divided by 3x is just 1, so this is minus the quantity x plus 21. Don't forget that this minus is for the whole fraction. And then 3x divided by 3 is x times 5. So simplify 9 minus x minus 21 equals 5x. We'll add the x over here, and we'll have negative 12 equals 6x. Divide by 6 and get x equals negative 2. But we're not done because we need to do a check really quick. So 3 over negative 2 minus negative 2 plus 21 over 3 times negative 2 should equal 5 over 3. So this is negative 3 over 2 minus negative 2 plus 21 is positive 19 over negative 6 minus a negative makes this positive plus a positive. And we'll times by 3 here, times by 3 here. And so this is negative 9 plus 19 over 6. And that's going to equal 10 over 6, which reduces down to 5 over 3, which is exactly what we wanted. So our answer is definitely correct. So flipping the page, a couple more examples here, starting to get a little bit trickier. So this one is intended to trick you. Notice the denominators are exactly the same. When the denominators are the same, you can just ignore them. And this translates straight to x plus 6 should equal 2 times x plus 2. And then we just simplify and solve. X plus 6 equals 2x plus 4. We'll minus x and minus 4 from both sides. And we get 2 equals x. Now, here is where you absolutely need to make sure you are checking your work, your answers. And why we do this, because now when we go to check, while I may have crossed out the denominators, when I plug it back in, it needs to go into the denominator. And this should equal 2 times 2 plus 2 over 2 minus 2. And hopefully you see the problem here. 2 minus 2 equals 0. So one thing that you may want to get in the habit of is identify your domains first. Anything that's not in the domain cannot be a solution. So this is not an answer, which means that there is no solution to this problem. As we can see, our one solution results in something that does not exist. It's undefined. So be aware of that while you're working these out. So along that vein, in this one here, my domain is x cannot be 3 or negative 3 from these two. And same thing for that one. So if I make this note here when I get to the bottom, well then I know that I don't actually have any solutions, or I can eliminate solutions quickly and easily. So now we go back to our usual. Again, this is a little bit of a trick. It's trying to trick you. Notice that x squared minus 9 is our difference of squares, and it factors to x minus 3 times x plus 3. So our LCD is just x squared minus 9. And I'm going to multiply everything by that binomial. All three terms. X squared minus 9 divided by x minus 3 leaves us just x plus 3 times that 2x. X squared minus 9 cancels with x squared minus 9, so this is just plus 6 minus 2x. And then when the x plus 3's cancel, we'll be left with x minus 3 times that x on the outside. Now we simplify and solve. So this is 2x squared plus 6x plus 6 minus 2x equals x squared minus 3x. It's got some quadratics, so we're going to move everything to the left side. So we have 6x plus 3x is 9x, minus 2x is 7x. We have the plus 6, and now we have x squared. This is just a plus, not an equals. And so now we're factoring what multiplies to 6 and adds to 7. That's going to be 6 and 1. So this is x minus 1 and x plus 1 and x plus 6 equals 0. And so x equals negative 1 or negative 6. We can look at our domain. It's none of these, so we know that we need to check both of them. And I'm out of space, so I will leave that check to you. So check as practice. Alright, so turn of the page. We have probably the hardest of the examples here. This one, again, it's trying to trick you. What you want to do is factor everything first. So 2z cannot be factored. I can factor a z out of this to make this z plus 2. And this gives you an idea of what this should be. So if this is going to factor nicely, we should look for it to be something times z plus 2. And in fact, that is the case. The binomial that needs to be here is 2z minus 1 to FOIL out to equal this. I realize my z's are looking a little funky here. 2z minus 1. So now when I go to decide my LCD, I need a z plus 2 from both of these. I need a z. I need a 2z. So that means I need a 2z, a z plus 2, and then I need this 2z minus 1 as well. And I'm going to multiply everything by that term. So when I multiply to this first term, The only thing that's going to be left, since it factors to these two binomials, is this 2z. So this will be 2z times z. When I multiply it to this one, the binomial terms, z plus 2 and 2z minus 1, will be left. And when I multiply it to the final term, the z and the z plus 2 will cancel, and I'll be left with 2 times 2z minus 1. And now all that's left is to simplify and solve. So we get 2z squared minus, we already know what this is, I don't need to FOIL it out, it's this thing, so I'm just going to flip the signs, distributing the negative appropriately. So 2z squared minus 3z plus 2, excuse me, and then this equals 3 times 2 times 2 is 12z, and then minus 6. Now we simplify and solve. 2z squared minus 2z squared is going to cancel. I'm going to add the 3z to this side, add the 3z to this side, add 6, and so I'm going to have 8 equals 15z, divide by 15, and we get z equals 8 over 15. Again, when we go to check this, we have to check it in the original, the fraction. So I'm going to plug that in. Let's see, I think I could fit it in right here. So we have 8 over 15 over, I'm going to use this version, 2z minus 8 over 15 times 8 over 15 plus 2. This would be minus 1 over 2 times 8 over 15. And then this should equal 3 over 8 over 15 times 8 over 15 plus 2. Oh, this is 2 times 8 over 15. That should have been. So this is going to be 8 over 15 over 16 over 15 minus 8 over 15 minus 1 over 16 over 15 should equal 3 over 8 over 15, and 2 is 30 over 15. So this is times 38 over 15. Looks like I didn't have enough space here. We'll come over here. I realized I did this. Sorry about that. Okay, so 16 over 15 minus 8 over 15 is just 8 over 15. So this becomes 1. 8 over 15 divided by 8 over 15. This becomes minus, flip and multiply, 15 over 16. And this should equal 3 times 15 squared over 8 times 38. So 1 minus 15 sixteenths is 1 16th. And this is a large number, so we'll use our calculator for that. But it looks like I do have a slight error on this number. So this, I forgot this, so this is also 30 over 15, so this should be times 38 over 15 here. So that does change it slightly. That's 8 over 15 over 8 over 15 times 38 over 15. And then this would be then minus the 15 over 16 equals 3 times 15 squared over 8 over 38. So this is a lot of fraction work, but what happens is the left side actually simplifies down to what we get is negative 24 over 15 plus 30 over 15. And this whole gross thing actually simplifies all the way down to 6 over 15. And we can see that 30 minus 24 is going to equal 6. Now, to be fair, catching this error, I did do a bunch of extra work because I lost my mind a little bit. So you can see I did a bunch of work here because my error was driving me crazy. So it's just about being careful with your fractions. So if you don't want to have to do as much work as I just had to do to fix that error, you want to make sure that you are very, very careful when you're plugging things back in. Also, a little shortcut here that we didn't talk about. Our domain is very specific. Z cannot be 2, it can't be 0, and it can't be 1/2. So as long as our answers are not these, which they are not, you can actually plug it into this step right here, and it will make your life a little bit easier. What you can't do is plug it in down here, because of course this will give you a right answer. But if you plug it into this step, or actually better yet, this step would be safer. You can do that as long as none of your answers are in the domain. If even one of your answers is in a domain and you eliminate it, you need to plug your other answers back into the original. So, some practice problems for you to work on. This is usually the hardest section of this chapter, so take your time. Don't wait to the last minute before the exam to work on your practice and your homework either.